This is Janine White's weekly summary for week 6 of Physics 111. This week we had to do 2 labs, Chapter 8 and Chapter 9. Chapter 8 was about lists, loops, and ifs. Here you can see 10 balls going across the screen, changing color as they hit the right and left edges, and then also they are looping around the edge so that they have to change direction whenever they hit an edge. Then, for Chapter 9, we added a shooter. And there's just 4 balls. And you can see that it's there's no collision detection. The balls aren't disappearing if you hit them. It's just the movement of the shooter. You can make it go faster or slower. One thing that I added was stopping the shooter at the edge of the screen. You can shoot up to 10 bullets at a time. Then it stops. You have to press the R key to reload, and then you can shoot some more. Those are all features from the lab. And the other thing that I added here is that I did add comments to my program to ensure that I understood what was happening throughout it. Next, I also participated in the Did You Know discussion, or Shift Happens. I wrote my own response, and I also responded to several other people's comments. In this case, I had seen the presentation, or at least a version of it, previously. It's primarily about the speed with which technology is changing and keeping up globally. That information becomes outdated quickly. I think that some of the statistics are, I'd like to actually see the references for some of those statistics. But in any case, I do agree with the basic idea, which is that you do have to keep up. You definitely have to continue to learn. And it's something that's important in my work. Right now, I'm spending 2 hours a week teaching my team, or not 2 hours a week, 2 hours a day, teaching my team everything that I've learned in the last year to make sure that our manufacturing techs can take care of defects. Trying to pass that on as we bring in new processes, very rapid change. The whole team has to work together as efficiently as possible. Constant learning. I'm in classes learning, getting another degree to keep up with the certifications, basically, that are required to advance, as well as to have basic knowledge that helps me continue to learn in my job, and just because I want to. I think that the video is a little scary for students who haven't been around as long as I have. There is a rapid pace of change. I think what's important in college is to get the fundamentals, understand, get your math, your science, your communication, so that you understand the world around you. You can make good decisions, and you can add to that fundamental knowledge moving forward throughout your life. It's very hard to keep up if you don't have a good base to grow from. So that's really what's important about college, besides just getting a certification. For the NEAT resource, I made available the website for the Large Hadron Collider, as well as a cool picture from the CERN ALICE experiments from the first lead-ion collisions. Pretty neat. And a link to a video explaining how protons are actually accelerated within the LHC. So altogether, I also spent a good bit of time this week at work as I was working, just listening to videos on Higgs bosons, and so it's really an interesting area of study that could revolutionize that is revolutionizing our understanding of space and energy. I also spent time working on the controversial debates. I provided pro and con for both intelligent design and the moon landing. Some of these topics are pretty interesting, fun to research. In terms of intelligent design, my pro is that students really already know the intelligent design argument. They've heard it in their churches or, you know, in their life. So it's not that we'd really be hiding anything from them, and by not allowing that to be explored in depth, the student, you can't really refute it in depth either. So it makes it look like the evolutionary theory can't combat it, so we're just ignoring it, when that's really not the case at all. On the con side, intelligent design is a failed theory, and there's not really that much. There's not a lot of point to really discussing it in detail. It's like alchemy, or flat Earth theory. You might mention it in passing that this is an alternative theory that some people still believe, but in the scientific community, it's not credible. So it's also can be, the con is that it's a waste of time to discuss it, and so teachers certainly shouldn't be forced to teach it in their classrooms. For the moon landing, what I found on the pro side, it was interesting. I found an analysis of parallax and stereoscopic parallax in the lunar photos that were taken, and the argument was that by analyzing the photos, they found that they really couldn't have been more than 300 meters away from the background because it shifts in the photographs, and therefore it must have been a set that they were taking the pictures on. And interesting. And then on the con side, I said, well, we actually have moon rocks that were brought back by the Apollo missions, including the one in question, the moon landing itself. And and the moon rocks do have a different composition than Earth rocks, as well as lunar soil samples that they brought back that have no organic matter, as expected, with no atmosphere and no water on the surface, or very little. So there's strong evidence that we at least actually have material from the moon available. So I'm looking forward to participating in more controversial debates. And then I did publish my notes, and I will put a link to my notes available in the video summary. So thank you very much, and I will post again next week.